Hello everyone, welcome to Think Global Education Services SAT Math class. Guys, this is my second video on geometry. In the first video, I covered circle. Now I will be covering the basic part of triangles here. So we'll understand few properties that we need to understand in triangle. So let's start, guys. The first very basic property that the sum of exterior angles for any n side polygon. Okay, so for that, let me take a triangle. Let's try to relate, or let's try to understand the formula. So if I take a triangle, let's say this is the triangle, I label it as A, B and C. Now if I say small a, small b and small c represents the interior angle of the triangle. Now you acknowledge the fact that if I want to draw the exterior angles of the triangle, I have to extend the lines. Now I can extend them whichever way I want. I can extend them clockwise or I can extend them anti-clockwise. So I'm extending them anti-clockwise. So let's say if I extend the line like this, then this line like this, and this line like this. So I've extended them anti-clockwise. And if I say the exterior angles, let's say this exterior angle is 1, this exterior angle is 2, and this exterior angle is 3. So ABC represents the interior angle and 1, 2, 3 represents the exterior angle. Now, I believe you remember the property that every exterior angle is always equal to the sum of opposite interior angles. So in this case, if I take angle angle 1 will be equal to the sum of opposite interior angle, that's B plus C. Similarly, if I take angle 2, which will be equal to A plus C, and if I take angle 3, which will be equal to A plus B. Now if I try to add all these three equations, I will get 1 plus 2 plus 3 is equal to twice A plus twice B plus twice C. So from here I can say 1 plus 2 plus 3 is equal to, I'll take 2 common, A plus B plus C. And I know the value of A plus B plus C is 180. That's the sum of interior angles of a triangle, and twice into 180 will be 360 degrees. And this 360 degrees is nothing but 1 plus 2 plus 3, which is nothing but sum of exterior angles. So sum of exterior angles, so I can say the sum of exterior angles of a 3-side polygon. Sum of exterior angles of 3-side polygon. Triangle is nothing but a 3-side polygon. Now I just derived the exterior angle of a 3-side polygon, but the question is asking me the sum of exterior angles for any n-side polygon. Now you need to understand the sum of exterior angle for any n-side polygon will always be 360 degrees. I've derived it for a 3-side polygon, but it really does not matter if it's a square or a pentagon or a hexagon or a decagon. The sum of exterior angles for any n-side polygon will always be 360 degrees. Why? You need to understand that every exterior angle can actually be represented as an angle at a particular point, and the sum of the angles around a particular point will always be 360 degrees. So I'll explain you what I just said. I said the sum of exterior angles for every exterior angle can actually be represented as an angle at a particular point. So for that, you have to visualize a bit. Do you realize if I start shrinking the triangle, so if I start shrinking the sides, do you acknowledge what will happen to the triangle? The triangle will converge and become a point, and the figure will actually look like this. So the triangle will converge and all these three exterior angles will come and meet at this particular point. So this will be angle 1, this will be angle 2, and this will be angle 3. So do you realize I can say the exterior angles are nothing but the angles at a particular point, and the sum of all the angles around a particular point will always be 360 degrees. So it really does not depend on the figure. I can take one more example of a quadrilateral. So for example, if I say there's a quadrilateral, and for this quadrilateral, if I want to extend, I want to draw the exterior angles. So I'll extend the lines. Let's say I extend them anti-clockwise like this. So I extend these 4 lines. Now, let's say the 4 exterior angles. Let's say this is angle 1, this is angle 2, this is angle 3, and this is angle 4. So what will happen if I start converging the figure? If I start converging the figure, it will again will look something like this and will actually become a point. All these 4 angles will converge at a particular point. So I can say that this angle will be 1, this will be 2, this will be 3, and this will be 4. So all these 4 angles will converge at a particular point, and again the sum of all these exterior angles will end up being 360 degrees. So the bottom line is the sum of exterior angle for any n side polygon will always be 360 degrees. So whether it's a triangle or a quadrilateral or a hexagon, it really does not matter. So I hope this part is clear. Now, moving on to the next part, which is the sum of interior angles for any n side polygon. The sum of interior angles for any n side polygon. Now for that, again a small logic that you need to understand. So here I will again prove this for a triangle. A triangle has 3 vertices, right? Vertices means corner points. At every vertex I can clearly see there is one exterior angle and one interior angle. And I know the sum of one interior angle and one exterior angle at one of these vertices is 180. At this vertex also it's 180. At this vertex also it's 180. So at one vertex 180, at 2 vertices twice into 180, at 3 vertices thrice into 180. So I can say for any polygon, it really does not matter, the total interior angle plus the total of exterior angle will always be equal to n times 180. I just proved that the total exterior angle is always 360. I'm concerned with total interior this time. So total interior angle for any n side polygon comes out to be n times 180 minus 360. So if I take 180 common, so that's n minus 2 times 180. So this is the formula for the total of interior angle for any n side polygon. So I can say n minus 2 times 180 degrees. So if I say for a triangle, there are 3 vertices, so it's 180 times 3 minus 2, that's 1, so that's 180 degree. So for a quadrilateral, I know it's 180, 4 minus 2, that's twice, so that's 360, so on and so forth. For a pentagon, 540, so on and so forth. I can figure out the interior angles for any n side polygon. So guys, the sum of exterior angles always 360. The sum of interior angles is given to me by n minus 2 times 180. I hope both these basic formulas are clear. Now moving forward, Pythagorean theorem. Guys, this is the most basic theorem that we ever learn. So that's the first theorem that is tested or that we ever learn in our 8 or 9 standards. So that is hypotenuse square is equal to perpendicular square plus base square. So in this case, a square plus b square is equal to c square. That's the Pythagoras theorem, and I believe everyone is aware of this. Now, in our SAT, they really do not test me on Pythagoras theorem because they already know that I'm aware of it. So whenever they give me Pythagoras theorem in my SAT, they only talk about three Pythagorean triplet, which you should actually remember if you want to, be quick in your SAT exams. And these three Pythagorean triplet are 3, 4, 5, 6, 8, 10. So the point that I'm trying to make here is if the perpendicular and the base. So for example, if I say the perpendicular is 4 and the base is 3, the hypotenuse has to be 5. These three dimensions follow Pythagoras theorem. Similarly, if I say the perpendicular and the base is 6 and 8, the hypotenuse has to be 10. And the third Pythagorean triplet is slightly orthodox one, which you need to remember, which is 5, 12, 13. That means if the perpendicular and base is 5 and 12, the hypotenuse has to be 13. Now, why I am asking you to remember this? Because 99.9% of the times in your SAT, if you find Pythagoras theorem anywhere, you'll just notice that these three dimensions, either one of these three will be given. So that makes my job easy if I already remember them. That's 3, 4, 5, 6, 8, 10, and 5, 12, 13. So make sure you just remember them. That will make your job easy in your exam. Now, the next important property is triangle inequality property. That's a very important property and a very interesting one. So let's understand what is this triangle inequality. So for that, if I give you an example, try to make a triangle, let's say something like this. If I take a triangle, something like this, join these two sides. So that's a triangle. So let's say A, B, and C. Now I'm assuming that AB is 4, AC is 4, and BC is 3. Now here, guys, you need to visualize a bit. If I take this point A, and if I start bringing this point A down, like this. So do you acknowledge this AB will start to stretch? So as I'm bringing this point down, AB is increasing, increasing, increasing. At one point in time, A will come here. When A comes here, this AC is 4, which is lying flat now. So do you acknowledge as I was bringing this point down, AB was increasing, and at this point, I'll get the maximum length of AB. At this point, I'll achieve the maximum length of AB, which is 4 plus 3 is equal to 7. But the point is, when I bring this point A down, is it a triangle anymore? No, it's not a triangle. It has actually become a straight line. For a figure to be a triangle, this A should be slightly up. And if this A is up, this AB will definitely be less than 7. And what is this 7? The sum of other two sides. So I can say for any figure to be a triangle, the third side of a triangle, no matter whatever you do, will always be less than the sum of other two. Because if it becomes equal to the sum of other two, it will no longer be a triangle, it will actually become a straight line. So the third side of a triangle, so this side has to be less than 7 for sure. The third side of a triangle has to be less than the sum of other two sides. Otherwise, it won't be a triangle anymore. So let's take one more example and try to understand the other scenario. This time, if I say, for example, let's say this is the triangle. This is A, this is B, and this is C. And let's say this is 4 and this is 3. Now this time, if I start bringing this point A, bring this point down anti-clockwise like this, do you acknowledge this AB, as this A goes down, this AC will start to shrink, and at one point in time A will come here. That means this AB will actually overlap this BC, and in that case the length of AC will be minimum, that is 4 minus 3, which is 1. But when it happens, they realize it won't be a triangle. For this figure to be a triangle, this A should be slightly up, and if this A is up, this AC will definitely be more than the difference of other two sides, that's 4 minus 3. So I can also say the third side of a triangle, no matter whatever you do, will always be greater than the difference of other two sides. Now, guys, this is called the third side rule of a triangle. Third side rule. And if a triangle does not follow this rule, it simply cannot be a triangle. So if any side does not follow this rule, we cannot form a triangle. For a triangle to be formed, every side should follow the third side rule. Otherwise, it cannot be a triangle. So it's a very interesting and very important rule. Now, so if I say which of the following can be the dimension of a third side of a triangle. If I look option number A, 6, 6, 12, it cannot be a triangle because the third side is actually equal to the sum of other two sides, not possible. Similarly, when I say 7, 3, 10, can it be a triangle? No. The third side I can clearly see is equal to the sum of other two sides. If I give you a protractor and a scale also, you cannot draw a triangle with these two dimensions. But if you look at option number C, every side follows the third side rule. If I take 10, 10 is always less than 6 plus 5, and it's always more than 6 minus 5. So less than the sum of other two sides, greater than the difference of other two sides. If I take 6, 6 is always less than 10 plus 5, is always more than 10 minus 5. And similarly, if you take 5, 5 is always less than 10 plus 6 and always greater than 10 minus 6. So if you notice, all these three sides follow the third side rule, and that's why it can very well be a triangle. So this is a universal rule for a triangle. If any side breaks this rule, a triangle simply cannot be formed. So that's a very interesting rule, and guys, you need to understand, it will never be spoon fed it to you. They will never ask you directly, okay, this is the side, what are the possible length of the other sides? No, it won't be like this. So they will put this rule beautifully in a question. So let's understand how they will actually test you on third side rule. So here it is given the figure, not drawn to scale. Okay, so I'll believe the information given to me. It's a quadrilateral shown above where AB is equal to AD is equal to 10. So I know this dimension is 10. I know this dimension is 10. And BC is 5 and CD is 5. They are asking me which of the following can be the measure of angle BAD. So I'm looking for this angle. Now, guys, understand this. This question has nothing to do with the quadrilateral. It is dealing with the third side rule. So let's understand. If I'm worried about angle A, let me try to join the side in front of it. Now, this is the third side of a triangle, and I can clearly see this BD. Let's say the length is X. And if the length is X, I know this length will definitely be less than the sum of other two sides, that is 5 plus 5. So I can clearly say that this X will definitely be less than 10 for sure. Now, so let's hypothesize for a moment. For example, if I say that BD is 10, suppose. So do you realize if BD is 10, AB is also 10, AD is also 10. So it would have been an equilateral triangle. So if BD is 10, it will be an equilateral triangle, and angle A would have been 60 degrees for sure. But in the real scenario, BD is not 10. BD is actually less than 10. Now, guys, basic funda, if the side goes down, the corresponding angle will also go down, right? So if the side is less than 10, the angle will also be less than 60 degrees. So I can definitely say that angle A cannot be 60, because if it would have been 60, the side would have been 10, but since the side is less than 10, so the angle in front of it will also be less than 60. And when I look at the options, B cannot be my answer, C cannot be my answer, and D cannot be my answer. So it has to be A. There's only one option less than 60 degrees. Now sometimes student says, sir, that's a weird way of doing a question. You are not solving it, you are trying to approximate it. But if you read the question carefully, they are asking me which of the following can be the measure. They are not asking me which of the following is the measure. So that's a hint that I have to approximate it, and I can approximate it by using the third side rule. The options are designed accordingly. Now, if you are wondering why we are not calculating it, because we cannot calculate it. Guys, if I give you four sides, you cannot tell me the exact value of A. That's impossible. You cannot do that. Why? Because maintaining the sides to be same, I can vary the angle. That's actually the difference between the square and the rhombus. If you see a square, I know all the angles are 90 degree. The sides are same. Let's say 2, 2, 2, 2. Now, do you realize if I slightly distort the figure will look like this. Now here, I know the sides are still 2, 2, 2, 2, but all the four angles changed. So the point here is, and that's actually the difference between a square and a rhombus. A square, all sides are equal. Rhombus also, all sides are equal. But in a square, all angles are 90 degree. In a rhombus, the angles are different. So maintaining the sides to be same, I can actually vary the angle. So there is no one particular value for angle A. It will keep on changing. According to third side rule, I can predict that it will always be less than 60 degrees, and hence it will always be 45 degrees. So guys, I hope you understand this third side rule. Very interesting. A very good question can come from here. So we discussed few basic rules of triangle in this, and I will be making more videos on triangle. There are lot more to cover. So guys, I hope you enjoyed this video. So bye bye guys. Thank you.